Good afternoon. Today we are starting our next unit in math. We are going to be working with algebraic expressions. Some of these things we've already learned about, and some of these things we're going to build upon our previous knowledge to learn new things. So we're starting off with PO60. This is a power objective. Super important. Power objective. You will be using this forever with math, okay? Not just pre-algebra class learning. This is stuff that we will build on and build on and build on over the years. Today with PO60, we're learning how to simplify algebraic expressions, how to make them more simple. Just think about like those fractions, how we are dividing stuff out so we can divide it down to simplify fractions. We're going to learn how we simplify algebraic expressions. So we're going to look at each of these groups of objects and we're going to write each group as an expression. So look at the soccer balls and the basketballs. How could we write that as an expression using our variables to stand for the different types of balls? How do you think we could do that, James? Okay, for soccer balls, we could call it S. For basketballs, we could call them B's. Now we need to write an expression. 4S plus 3B, because we have 4 soccer balls plus 3 basketballs. I'm not going to put the equals in. Why do you think I'm not going to put the equal sign in? Because it says write it as an expression. When we're writing an expression, there's no equal sign. It's just 4S plus 3B. When we write an equation, we're equating one side of the equal sign with the other side of the equal sign. 4 plus 3 equals 7. We can't say that right now because we don't, if we're using the S and the B as variables, we can put in different numbers into there. So if we're doing proportions, it would look differently. So we are just doing the expression right now. So let's look at our next group. How could we write an expression for our second grouping? What do you think, Emily?
2L plus 4B plus 3B.
2 lamps plus 4 chairs plus 3 beds. Okay. So remember, the expression means we're not using the equal sign because we're not equating two sides to equal each other. It's just an expression. So in our algebraic expressions, we have lots of different vocabulary that we need to learn. We've gotten exposure to some of these words and what they mean. Now we're really going to make sure that we understand them. So our first word is the term. A term is a part of an expression terms are separated by addition and subtraction. An example would be 4C minus 10C squared. Okay, this would be a term, this would be a term. They're separated by that subtraction sign. So when we were learning about the slope-intercept form, y equals mx plus b. So think about when we did that, y equals mx plus b. If there was a number in front of the y, we said we had to divide all the terms by that number. So we divided by 3, we divided by 3, we divided by 3. Because mx is a term, and the b is a term, and the 3 is a term. Yeah. So the term is separated out. Yes.
How do you know if you're adding or subtracting?
Well, it says it. Mx plus b. Okay, so it doesn't matter if you're adding or subtracting. It's just this is a term and this is a term. It's everything that's being separated out that's together.
The top, like, how do you know? Like, where it's wherever.
Because that's one expression we could pull out of that grouping. That's one example. Those are examples. Yep. So the terms are the things that are separated. It's not just a number or just a variable. They're connected. So up here, it's actually 3y is our term. 3 divided by 3, and we're left with just the y. So it's a whole term. A coefficient is the number before the variable it tells you how many of the variable you have. So if we said 3n, that's the same thing as saying, that's an arrow. 3n is the same thing as saying n plus n plus n. There are 3 n's. Another way of doing n plus n plus n is saying 3 times n, right? N plus n is 3 times that n. So the variable is that number. So up here in our expression, 4 would be our variable. 3 is a variable. Altogether, 4s is our term. Sorry, not our variable. 4 is our coefficient. I am so sorry, I said that wrong. 4 is the coefficient. 3 is the coefficient. The term is 4s. The term is 3b. So the letter is our variable. The number that's connected to it is our coefficient. Together, they make up our term. Now we have our constant. The constant is a term without a variable. An example would be 9, could be -3, could be 11. Those are constant. There's no letter next to it. So when we looked at our slope-intercept, when we have y equals mx plus b, when we put that y-intercept in for the b, that would be a constant because there was no letter that we replaced that b with. We just put in the y-intercept. So we could say y equals -3x plus 5. That 5 is a constant. So if we had that for our y-intercept, y equals -3x plus 5, 5 is our constant. No letters, just number. So a constant is just the number when there's nothing next to it. You can't call the 3 down here a constant because it's next to the b. There's a variable there. So if there's a variable next to it, it's not a constant, it's a coefficient. If there's no variable, it's a constant. Like terms. Like terms are terms with the same variable. To the same power. So we could say an example would be 3x and 5x. So 3x and 5x are like terms. They have that same variable. It's not 3x squared plus 5x. They both just have one x. 3x, 5x. We can combine those. We'll see what that means as we go on. I know I'm getting low here, so just listen as I'm saying it. If you need to stand, if you're in the back and can't see what I'm writing, but I want us to have the space to write. So to simplify just means to combine like terms with adding or subtracting. We're combining them. If they're both positive, like our 3x and 5x, we can add them together and call it 8x. That's simplifying it. We're combining those like terms. So we could say 3x plus 5x equals 8x. Okay? So it's a lot of new vocabulary for us. These are the mathy terms that we need to know going forward. So we need to know what a term is, what a coefficient is, what a constant is, what like terms are, and what it means to simplify. This is very important. We are going to be making this a 2-day objective for a reason. It is that important for us to fully understand. I'm going to erase this so I can scroll up. So in each expression below, circle the coefficients, box the constants, and underline the like terms. Then simplify the expression. So, important thing to note, are we solving anything? No, there is no equal sign. We are not saying one side is equal to another side. So we're not going to say 3x plus 4x minus 9 equals anything. There's no equal sign here. We are not solving the expression. So we're going to remember what these mean. What is a coefficient? We're going to circle it. What is a constant? We're going to put a box around it. What is a like term? We're going to underline it. And then we have to combine our like terms to simplify. So let's see what that looks like. Well, first, let me ask, are there any questions about any of that new vocabulary? It's important that you have written down those definitions so you can refer back to them. Remember, addition and subtraction signs belong to the term that comes after them. So remember that we said minus is like the negative, adding is like the positive. It goes along with what comes after it. So when we see that there's a minus 9, that means it's a negative 9. Okay, so that we have our operation, adding or subtracting, it goes with what comes after. So let's look at 3x plus 4x minus 9. what's the first thing I'm going to do? Circle the coefficients. Where do I find my coefficients? Michael?
The numbers before the variables.
The numbers that are before the variables. Remember, the variables are our letters. So when I see a number before my variable, I'm going to circle them. Am I going to circle the 9?
No.
It's a number. Why don't I circle it, James? It's not in front of a variable. So I just circled the 3 and the 4. My next step is put a box around my constants. What is my constants in this expression? Hayden S? The 9. Our constant is what number is by itself with no variable. Now I need to underline like terms. So what are, I have 3 terms in this expression. What are my 3 terms, Chance?
I have actually going to ask you, wouldn't you circle the subtraction sign with it too? Because it says the additions of subtraction signs belong to the term that comes after them.
I did wonder about that when I went to do it. I think you are right. I think because that minus makes it a negative, I think we should put it around. You are correct. So put that box around that minus to make it a negative 9. That makes more sense. Okay, so now we need to tell me what the 3 terms are in this expression. Gus?
3x, 4x, and -9.
3x, 4x, and -9. And technically, it's based on what Gus or what Chance said, it should be the 3 and the positive 4. It should be that plus 4.
It's already a sigma.
But we circle it so we remember. So we have 3 terms. We have the 3x, the 4x, and the or plus 4x, and the -9. So we need to underline like terms. So which of those terms am I going to underline? Evelyn. Just the 3x and the 4x. I don't underline the -9 because there's no x after it. I cannot combine those. I can only combine the like terms. We have 2 terms with the 1x. So those are the ones I can combine. So now I need to simplify my expression. How do I simplify this? Chance? Were you ready? I thought, okay. Who thinks they know? James. Can you say that a little louder? The roof was making noise.
Because it says combine, but we just.
You either add or subtract them depending on what operation we have. So 3x plus 4x minus 9. How would I combine my like terms of 3x and plus 4x?
Add.
So what would that be?
3x plus 3, 7.
7. So it would be 7x. 7x are my terms I can combine. Can I combine my -9 with anything? Is there another constant I can combine it with? No. So then I just bring it down. So I combine what is similar, same terms, right? Got the same variables. And -9, there's not another constant. We will find that sometimes, I'm looking on here, sometimes we will have, let's look at our next one. Sometimes we will have constants that we can combine. So look at that next one, 11 plus 8n minus 5. First thing I want to do is circle my coefficients. What are my coefficients? What should I circle? Plus 8. because that 8 is in front of a variable. Next, are there any other coefficients? No, because there's no other variables in my expression. Now I need to put a box around my constants. So what am I going to put boxes around, Priya? -5 and 11. So what are my 3 terms that I have here? What are my 3 terms? Chance.
11, 8, and -5.
11, 8n, and -5. Those are my 3 terms. Which ones are like terms that I'm going to underline? I don't have any like terms.
Oh, you don't do.
Aiden asks, what are my like terms?
11 and -5.
11 and -5 are like terms. There's no variable with either of them. I can combine them. So how would I combine 11 and -5?
11 minus 5.
Yeah. What is 11 minus 5, Chance? 6.
And you get 6 plus 8.
So I'm looking at the answer key. The answer key brings down my 8n because I have no other n's to combine it with. So there's no like terms for my n. And then we have 11 minus 5 is 6. And then it says it's minus 6. So let's look at that. Let's pick a number to put in for n and see if it should be -6 or +6. So if we put a 2 in, for n, doing PERMDAS, first we have to do our multiplying. 8 times 2 would give me 16. 11 plus 16 is 27. 27 minus 5 is 22. So now if I put the 2 in down here, that would be 8 times 2 is 16. I think Mr. Schultz was wrong on this, and we didn't catch it last year. It has to be a +6.
Yeah, but that doesn't either add up. I know what that side
16 plus 6 is 22. So because 11 minus 5 is a +6, we need to put +6. So I think Mr. Schultz was looking at it and he saw the -5 here. And he thought, oh, I'm going to put a -6. But 11 minus 5 is a +6. So that would be a +6. Okay, does that make sense? Oh yeah, we're gonna make sure we understand these. We are not doing the second page today. So nobody should be turned to that. Nobody should be turned to the second page. Okay? Today we are fully understanding the term, the coefficient, the constant, the like terms, and what it means to simplify because it is that important. Tomorrow we're gonna add in another step and do that work. Or I might do the teaching of it today, and then we'll do the work tomorrow. We'll see how much time we have. So let's look at our next expression. 2y plus 9y plus 13 minus 13y. First thing, circle the coefficients. What are the coefficients that I need to circle? In S. Careful. Remember when we're circling and boxing, we're keeping that adding and subtracting with it. Okay, so we have the 2 with the 2y, we have the +9 and the -13. Okay, So make sure you're keeping that adding and subtracting with so you know if they're positives or negatives. No, not during the lesson. Priya,
Oh, for the,
you want to do the boxing?
yeah. You box positive 13.
We're gonna box the positive 13 because that is a constant. There's no variable next to it. So how many terms do I have altogether? 4. There are 4 terms. 2y plus 9y plus 13 minus 13y. There are 4 terms. So I need to underline my like terms. What should I underline? Which ones can I combine? J?
2, 9,
The whole term.
2y,
2y
2y, 9y,
plus 9y
minus
minus 13y. Okay, so those are my 3 terms that are similar. They all have that one y, that y to the first power. Can I do anything with my plus 13? Can I combine that to anything? No, there are no other constants. So my plus 13 is going to remain the same because I'm not combining it to anything. So now we need to do our math. 2y plus 9y minus 13y. What do I end up with? Evan? Negative 2. Negative 2y. Because 2y plus 9y gives me 11y minus 13y. 11y minus 13y leaves me with the negative 2y. Because 11 minus 13 is negative 2. That is my answer. Any questions so far? I know I'm taking this slow, but it's that important. Jan?
In the test, are you gonna want us to do like circles like
On the test, you're gonna have to be able to do this.
like the addition and subtraction?
On the test, you're gonna have to give me the final simplified expression. So you're gonna have to know what we can combine. Because let me tell you, there's a lot of times people forget that constants and coefficients are different. They are not similar, and they try to combine them. Let's do one more together. 14n plus 8n plus 3n. What am I going to circle? Tegan, what would I circle?
You would circle 14.
Plus 8 plus 3. All of those coefficients. And include in your circling and your boxing that operation that comes before them. So you remember if they're positives or negatives. So now I need to box my coefficients. What am I boxing? Nothing, because there are no constants in this expression. So I don't have to box anything. So underlining my like terms, what am I going to underline?
Everything.
All of them. 14n plus 8n plus 3n, because they all have n to the first power. They all have the same terms, so I can combine them all. So now I have to do the math. 14 plus 8 gives me 22n, plus 3n gives me a total of 25n. Am I solving it? Am I giving just a whole number? No, because there's nothing to solve. I don't know what n equals. We are just simplifying expressions in this objective. Not solving for anything, just simplifying. Any questions on doing the last ones on your own? Emily?
I think our next one, how do you simplify that? Because if there's
Oh, let's look at this middle one. So let's do it one step at a time. Okay, so we're gonna circle coefficients. So what am I circling for my coefficients? Who can tell me? Tatum.
20, -3, -2, and
That's it. Okay, so now I need to box my constants. What am I boxing? Priya?
Positive 13.
Positive 13 and -5. So, ooh, like terms. What are my like terms? Gus?
20n, 2n, and then another pair of like terms is
I have two different sets of like terms that I'm going to combine. Now, it's easy for me to show it with my different colors. I have my like terms that I underlined in blue, my like terms that I underlined in black. You can only combine the same type of like terms. So I would look at this and I would say, okay, I've got a 20n and I've got a -2n. So I can combine those to say 18n. Can I combine my -3x with anything? Nope, so I'm just gonna bring that down. I combine my +13 and -5. Now, what is 13 minus 5, Emily? So this would be my simplified expression. Okay, so you can have more than one variable in an expression. So, Jonas, we're not going to distract people, okay? I need to make sure we're all getting this. We can have more than one variable, but we can't combine different variables. I can't combine my 18n and my -3x because that's an n and that's an x. That's apples and oranges. They are different. The soccer ball, the basketball, they are different. We can't combine them together. So I have to keep them different. I can only combine like terms. The 13 and the -5 are both constants. If it's a constant, there's no variable. They are similar because they have no variable, so we can combine them. So it's super important to remember to only combine like terms. So somebody just asked on the test, do we have to do all of the circling and boxing and underlining? No, because your answer is going to show that you understand it. Can you do it? Sure. You can do it to make sure you're keeping it straight in your mind so that you get the correct answer. I'm only going to grade the correct answer. But you can circle and box just to keep it straight so you don't make those simple mistakes and accidentally combine that -3x with the 18n. You have to keep in mind what your like terms are. Does that make sense? So I want you to do those last 4 today. Tomorrow, we're going to do our second page. We're going to throw in a new thing with our expressions. And it's something that I've already talked about when we've done Khan Academy. I've already introduced it, so it's going to be newer. We're going to really be working on that distributive property tomorrow. Okay, so be ready to add that in tomorrow. Do not work on the second page. Do not work ahead. Please just do the first page today. When you are finished, work on your math packet, work on your Khan Academy. If you had any missing Khan Academies, make sure you're getting that done. Work on that math packet to make sure that you're understanding all the pages. I am going to, if we have time, I don't know if I'll have time before announcements to make the video for the math packet today. If I don't have time, I will do it this afternoon and put it on the YouTube channel. For my friends at home, we hope you are well and we hope to see you soon. Have a wonderful day.